Hey, recording's on again. Sam, if you're back, the floor is yours. I'm not sure how many people are trickling back. We could give a minute, but as before, we can be a little harsher given that we're recording and people can go back and rewatch stuff they may have missed if they missed a minute or two. So green looks good, Sam.
Right on. It seems to be advancing on its own. People can probably tab through this as they want. It does say 89 slides, but I promise it's not that boring. So Neil kind of gave me an idea that he wanted me to talk about, and I'm going to try and cover some of that here. And it's how you would run Prometheus, and that's really getting the data together. And I'm going to try and cover a bunch of this stuff. For some people, this is probably going to be beyond basic, and for some, it might be way above what they've ever done. I'm hoping to be able to share most of this out afterward, and then you can just use it as kind of a guide or a tutorial for some of this stuff. I think that advances the slide. There we go. So quick overview. I'm just going to talk about the common data needs here for analysis, some stuff that Neil already covered, and just as a recap, and then going to tell you roughly how to get parameters, hotspots, and do some operational adjustments. That operational adjustment is a key part. We don't really have data to support that, but that's kind of the intelligence aspect that we need to use here. Why are you changing your perimeter, your hotspot? What are you doing? What's the purpose of it? Things like that. I'm going to cover how you can get a fuels and elevation extract for a Prometheus run. And I was going to cover weather and weather stations, but I'm not going to do that anymore because I ran out of time because I made this all yesterday. So first off, got some common data needs. I'm really only covering basic stuff here, and there is much better, much more efficient ways to do what I'm going to show you guys, you folks. But this is a basic way to get at stuff, and I'm going to cover a few different things. You might hear things like API and SQL, SQL. I'm bringing it up. We're going to talk about APIs. It's programming interface. It's a coding thing, but it is also how a lot of this stuff is done. If you don't remember that, it's all good. Don't stress it. SQL is a querying language. It's often used in this kind of fire analysis, fire projection type world. But again, you folks aren't going to have to do that. You're not going to get tested on it. It's just bringing out some terms. So Neil already covered some of this, but I'm going to recap it. We have common data types that are used for, and I'm really keying this in on Prometheus. But these are some of the common things you're going to run into that you might have to interact with and deal with if you're going to do this type of modeling for fires or even just any kind of analysis. In the spatial world, we have two types of data. We have vector and raster. It's easy to think about vector data as polygons and shapes, points, lines, things like that, whereas a raster is a gridded cell-based structure. And I'm going to show an example of that to kind of cover off better what it is, but there's some common data types that you're going to run into, and that's what I'm really trying to get at here. For Prometheus, as Neil noted, you can use shapefiles and then KML and KMZs. That's just keyhole markup language. That's a Google thing. I'm sure most folks here are quite familiar with that for fire parameters and stuff like that. But you might also run into GDB and .gpkg file types. Those are, again, just extensions for vector data and sometimes raster, but don't worry about that. You might have to interact with it, though, to get things like a perimeter out of it, depending on where you work or what you're doing. On the other side, there's the raster data. So that's, imagine just, I'm being very loose with this, but like an Excel table is kind of a same approximation of a raster. It's a bunch of cells and rows and columns, essentially, with data in them, and then we use it to represent things. For the Prometheus side, you can use GeoTIFFs, ASCII grids, as Neil showed you, and then image files and those file extensions. And the file extensions are what I'm trying to get across here. Would be .tiff, .asc, and .img. So if you run into those, you know you can probably use it for Prometheus with some work. And there's all sorts of other data out there that we need to use for this type of work. XLSX and CSV, obviously more commonly seen in Excel. But then we have text files to, like, that's how your log file will come out from a Prometheus run. And then MDB is a Microsoft Access database, which you might have to work with if you need weather in some cases. I know Ontario used to do that a lot, and it makes for some more difficulties. And then MXD is just ArcGIS formatting. So what I want to show here is we keep talking about resolution, and people ask questions 30 meter, 100 meter, 250 meter. That's what I want to get at here. These roughly correspond to more common fire terms, which would be that 30 meter is closer to 0.1 of a hectare, 100 meter is about 1 hectare, and then 250 meter is 6.25. It just means the uh, length, basically, of the cell. And you can see there in this map I'm trying to show, this is somewhere in BC. You have a lot more fine scale data at that 30 meter resolution, but it really starts to aggregate and disappear as we increase in resolution. This has a lot of implications for the computational needs of your run. So if you're using 100 meter, it's going to be wildly faster, almost 9 times more data on the 30 meter side. So there is that. And I try to say that one thing I want to leave as an open question here is a fuel type really a fuel type when we get down to 0.1 hectares? It's a pretty small stand of trees. Can we really attribute it to a fuel type? It's something to think about when we start running these models when we have fire that's ripping across the landscape. It's probably moving a little faster than 30 meters a minute on large scale fires. Can this really pick up a fuel type signal? Just an open concept, something to think about. I tend to only use the 100 meter for modeling. When you get to 30 meter, it's very slow, very difficult. All right, so I'm going to cover off how to do some of this stuff in Arc Pro, but there's the ESRI suite Esri that most folks will probably be used to using here if you've used any GIS at all. I'm also going to cover how to do this in QGIS. And then there's R, which is a coding language, as is Python. That's how I do most of my work. Most of my fire modeling stuff and fire support is done through coding. But I'm not going to cover any of that because I think it's probably more advanced than most folks are going to be getting into here. But the point is you can do all of this in other software. And I'm also going to show how to do some of this stuff in Google Earth Pro because I think a lot of folks are still reliant on that as their primary GIS. And yeah, I'm not going to talk too much about Excel, but that's also a pretty frequent tool to do a lot of the data manipulation and changes you might need to do quickly. So like I said, I got 2 scenarios that I'm going to go through, and actually got a few more of that. But the first scenario is if you have a perimeter, but it's old, how can we update that and make changes to improve our modeling? And then the second scenario is you don't have a perimeter at all, and you need to get a perimeter, and then you need to adjust it. I'm going to basically cover all of that. But as a quick plug, if you folks know Colin McFadden, Colin likes to talk, and Colin's pretty good at that. And he's created a community of practice for the country to kind of talk about this stuff. If you want more info on this, please reach out to me or Colin, preferably, but I can link you up with Colin. Essentially, what this is an attempt through CIFC to bring all of the folks together from different backgrounds to talk about things like what I'm about to talk to, hotspots, remote sensing use in fire, and how we can utilize this work together and things like that. So it's not just for F-bands and it's not just for science people. We're really targeting that towards folks that work in fire and want to use new tools and get more advanced. And Dan, I'm not laughing at Google Earth users. I use it plenty. So we will start off fire perimeters. So I'm going to do this first run through with QGIS. This is Quantum GIS. It's an open source, no cost GIS option. It's not really common. Oh, my logo's covering stuff. Don't worry about that. It's not really common in the agencies to my knowledge, but we use it a lot at the CFS. It's used a lot in academia and research, and it's pretty easy to use, and it's a self-install. You can just grab it, throw it on your computer, and you can start using a GIS. For this type of stuff, I do recommend using it over other options because it's, like I said, it's easy. You don't have to worry about licensing. You don't have to worry about any of that stuff that you run into with ESRI. That download link works if you get this slideshow, but it won't right now. So scenario 1, like I said, we have a perimeter and we need to update it. I'm using an example perimeter here from Ontario. This is a Red Lake fire, and you can see here it's a shapefile. So Prometheus will accept KML and KMZ and shapefiles. Shapefiles tend to be pretty common ways to provide perimeter data out to folks. So you'll notice here the shapefile has 4 files in it. It can have more than that, but you'll generally see at minimum 4 files. There's the .shp, which is the file you actually care about, and the other pieces that are needed to do this. So they kind of all make up the data that makes that perimeter for you. and you do need to have all those files. So there's two ways to add a perimeter to a GIS, especially QGIS. There's drag and drop. That means literally click it and drag it into your GIS. I am not going to cover how to do that because if you can't do that, I have no ability to really get past that. What I am going to cover, though, is how to add data the proper way, which is through the data source manager. And I'm going to go through this a bunch. It's going to be not very exciting, trust me, but it's a lesson. So add through the data source manager, and we're going to go through these slides. It's going to be step by step. You click that button there. It says Open Data Source Manager. And then we can pull in our dialog box, and you'll notice that we've got vector file here and a bunch of other stuff that we're going to talk about as we go through. We want to add a vector file, so you're going to click File, obviously. And then you're going to click Source, and you click that to open another dialog box. And then we see we can get our shapefile, and we want to click that exact shapefile, hit Open, hit Add. There's a bunch of options that'll come up. These are completely irrelevant for the most part. They do matter, but they probably won't matter to anyone on this call. And if they do, well, you're probably more advanced than this lesson. Hit add and congrats, you've added your perimeter to a GIS and you can now see that. We're not going to see this perimeter again. It's not part of the lesson. It's just to show you how to get that in there to start. But now what we're actually here to talk about is the hotspot data and how to get it into your GIS so you can start doing this kind of manipulation and working with it. I'm going to go through two methods. There's the download and add side. I'm not covering this. If you want to talk about that or learn about it, I'm happy to help. What I am going to cover is the web mapping and web feature service. A lot of data is provided out by the agencies, the different provinces and territories, and the federal departments. And this is often through WMS or WFS services. These are ways of visualizing and seeing data without having to actually download and get it all. You can just overlay and start adjusting it. So I'm going to talk through two ways to get hotspots, and then we're going to talk about how we adjust the perimeter. There's tons of options out there for how to do this. Lots of people repackage it and resell it. But NASA firms, which I'm sure most folks are aware of and have used before, offers this service, as does the CWFIS in Canada as a Canadian solution. Both have pros and cons, and they require some intelligent use by the end user. You shouldn't just take this, trust it to be accurate. There are limitations and caveats with it. But with that said, this is one of our best sources for intelligence when we don't have people in the air, eyes in the sky, that sort of thing. So we're going to start off with adding hotspots via NASA. And again, these slides are all going to be there at the end. I'm just going to share this out. Hopefully it'll be useful. You're going to add hotspots via NASA. To do it with them, you need to get a map key from them, which you just give them your email. They'll send it to you. It's a unique code for you, and it lets you do 1,000 requests per 10 minutes. It doesn't matter. Don't worry about that. If you go over that limit, you are probably doing something way more advanced than this. You click through this, you'll get your map key, and then we're going to go here and you get a bunch of options that NASA offers up in terms of what you can get. My recommendation is grab Canada, but you can see there's the different provinces and territories there, like so, all that fun stuff. My laser does stick around. We're going to get Canada. That's the useful one, and that's going to cover off the Landsat sensors, the VIIRS, and MODIS sensors. So to add this, it gets a little weird. So you click that link there, the Canada link, and that's going to bring you to a page that looks like this. It's just an XML file. We don't really care about that. What we want is the address bar, and we're going to copy that. And then we're done with that. We're going to go back to our GIS. So now we have a perimeter in here, and we are trying to get some kind of data in it to start doing something. So you'll see there's a new option here, but first we want to connect via a WFS. That's that web feature service. And I will explain the difference between mapping and feature. It's basically the same process as adding the perimeter data, except we're going to this link, and then we're going to hit new. This is important. We want to change the name here and set it to something. You can name it whatever you want. It doesn't matter. I recommend calling it what it is, but hey, it's up to you. And paste the URL that you copied from the NASA webpage in there, and you'll notice that there is a your map key thing that's going to ask you to put that in there. That's the thing we got that was sent to your email. You put that between those two slashes, and then that's going to allow you to connect to it through your unique login. Hopefully this is clear and not the most boring thing ever, but it is. So next we're going to hit connect, and look at that. We can now see all the layers. There's a bunch of unique layers, and you can get a bunch of different stuff from NASA for this. I do recommend that you read through this and get a good feeling for what you're actually adding to your map. It can be a little It can be a little difficult. We're going to add this first one here, which is just viewers for the past 7 days, and then you hit add. You might see this pop up. It is a transformation for how you're going to display the data. If you're a GIS person, you can probably do something more useful. I recommend just hitting OK. It's defaulting to the most intelligent way generally. Anyway, once you've done that, you should see something like this. You see the Canada split off there and all the hotspots from the last 7 days. This is current. This is from yesterday. And now you can do lots of things like you can put styling, symbology, and all that stuff on it, but that is for another lesson. And that's that. We've added hotspots to a map. It's very exciting. Now I'm going to quickly go through how to do it from the CWFIS, which is the Canadian solution. Still leveraging the same satellite sensors, but it does offer some additional intelligence to it. Not necessarily the best or trustworthy, but it is there. Some things are scrubbed out, like persistent heat sources that are just, I don't know, an oil well flaring off. Those aren't going to show up as often in our version of it. And it does tag general FWI and FPP outputs. So you can get a rate of spread estimate, a fuel type estimate, fire weather estimate for that point. Again, super coarse spatial resolution, so it's not necessarily trustworthy, but it is a good little gut check in a way. For this one, the links, I should have said this at the start. I've got a Word document I put together with all these links, all the agency specific, where to get their perimeters, how to get their data, and I'll forward that around near the end of the course once I get it finalized. And the idea is you folks will be able to just do this all on your own. You don't have to go hunt for all the data. On the CWFIS side, you want to do this, you find your web service link and you'll just copy that link. It tends to download the XML file from the CWFIS for some reason, and that's not useful here. It'll do the same thing though. We're just going to go back into QGIS, except now we're going to add the WMS, and you hit new, same as before. Put your URL in, name it something, and that's it. As a side note, and this is where I'll explain what the difference between these things actually is. A WMS is essentially the same thing as a no, that's a bad way to say it. A WMS is an image, you can see it, but you can't get the data. Whereas the web feature service, the WFS, you can select pieces out of it like points or polygons and directly save them from that without having to go through a bunch of steps. You can also, in most cases, if you have a WMS service, just literally go through that URL and change where it says M to an F, and it becomes a feature service and lets you steal the data. So we can now add hotspot layers. There's a ton of different data and layers that are held in this one, a little more than the NASA one. What we care about is that hotspots for the last 24 hours. We're going to select it, we're going to add it, and now we have this. We've got our entire hotspots from the last 24 hours as of yesterday. So we've done that. We now have an idea of how to get these hotspots into a GIS so you can start doing some manipulation and working on your data. This is useful even if it seems boring and straightforward, because now we can start adjusting perimeters, finally. Side note, in QGIS at least, there is an XYZ option. This isn't important in ArcGIS for reasons you'll see. It lets you have a default of OpenStreetMap. You can add it in so you have an underlying base map to kind of keep yourself oriented as to what you're doing. But now we're going to start adjusting those perimeters. And so this is the same thing as I showed earlier, just zoomed in somewhere in the US because I didn't have enough hotspots in Canada anywhere. This is a fake perimeter, but this is a real fire. I drew this perimeter by hand. It's what we're going to use as our example here for adjusting it. You can see there's a bunch of hotspots. They're well spread out. What does that really tell us? Not a ton. We know that there's probably fire there, but we don't know the exacts. And the coarseness of this is, of course, coarse. So to start with in QGIS, you got to activate your digitizing and advanced digitizing toolbars. If active, skip it, doesn't matter. But if so, you just right click on these toolbars up here, and then you'll see under this section what you need to turn on. You do that, and then we can go here. We can basically, we'll see this as the UI. We've got this little toggle editing button. I realize the screen's small. We need to select the perimeter layer that we want to adjust. So that's this one, and then hit that editing thing. And that's going to bring us to here where we can start to reshape our features and actually start doing what we're here to do, which is adjust this when we need to do something. Side note, there is a snapping option. Highly recommend you use this. It's not actually needed, but it's incredibly useful to make this less of a pain in the ass. So now all that boring stuff's out of the way. adjusting the perimeter itself, and this is actually what takes some thought here. You can't just take it and turn it into a whole perimeter. This isn't all fire. I said that a few times. Most likely, I would estimate that most of this, probably out to about here, would be real fire. This is probably something that was caught up, but I mean, right in the middle of the road, things like that. It's not super accurate. We need to make a decision though and say, like, if this was a real fire, we probably saw a bunch of spread coming out from this way. Something happened, but we want to not just draw a big circle around it and say this is now fire. We got to start making some decisions on it. So you'll see this pink square. That's what the snapping thing I talked about does. It lets you select a point where you're going to start. And essentially, you just, once you start reshaping your features, you click around a bunch like that. I think the piloter comes through and you can make a choice as to where you think this fire actually went. It doesn't need to be accurate because you can't make this perfectly accurate from hotspot maps. We're obviously not in the air. If we had a helicopter to go up and map it, we'd get a much better output. But let's say for some reason we can't fly today and we still need a projection. We're gonna do something, and this might be the most useful we can get at. So you basically build out that shape that you're suggesting you think best fits what actually happened in that fire run or where that fire might actually be. Again, we've got to recognize this isn't perfect and there's going to be constraints and issues with it. This is a very rough adjustment here. But once you do this, you bring it back in, you click on there, and then you just right click it like I got there, and bam, you've got a new perimeter. It's extended out. That's literally the entirety of this. You've now got that perimeter. You can hit save up in the corner. This will alter the original file. So if you don't want that to happen, save it as a different file. But otherwise, you now have a new perimeter, and this will fit right into Prometheus. So you can start running your projection. So you're going to do all that again, but I'm going to do it in ArcGIS Pro. I can skip this too if people want, but I'm happy to go through it. It's not very exciting. I realize that. But a lot of the startup of doing a fire projection is not fun. It's not exciting because you're just doing data collection. So if your agency is still using ArcMap, this might not be the most useful thing for you because ArcGIS Pro is very different from what ArcMap 10.4 looks like. But regardless, it's kind of the same thing. And this is we don't have a perimeter scenario. So if we're starting from QGIS, ArcGIS, let's say you've got to your incident, there's no perimeter available, and the ICs or the plans chief is demanding a projection in the next 2 hours. You got to do something. No one's even flown it yet. Maybe you're going to use Prometheus. I probably wouldn't, but hey, here's what we're going to do. So in this case, make a new map. I recommend the map template for reasons you'll see. Select your map and name the project something, and then just give it a location to save it to. ArcGIS does some nice things. It makes a folder for you, so all your data will just live there and you're good to go. But once you do that, it'll create your project. And one of the nice things with ArcGIS Pro is it overlays this base map with a hill shade under it, so you can actually see elevation changes and things going on like that. Anyway, we've done that. We're going to do the same thing. We're going to add a new WFS service. There's these tabs up here, much like Microsoft Office. We want the Insert tab, the Connections server, and the new WFS server. Click that, we go through that, and that's going to bring up this page, which is add a connection. It's a little different looking, but it's mostly the same. And so I'm talking here, this WFS is going to get us a perimeter. And if you notice this is Saskatchewan, don't use this one. You shouldn't be able to access it. Most agencies do provide this as a service, though. I don't know how many people realize and recognize that perimeters are shared publicly pretty much by every province and territory through links like this where you can just pull it in, as well as the federal government through the CFS in a slightly different format. So if you don't have anything and your GIS folks are overloaded, you can generally still get something to start with. So you'll add your WFS here. And then a little differently, you'll have to change tabs. So we were on the Insert tab. We're now going to go to the Map tab. We're going to hit this Add Data button, and then we're going to add data to the map. And that just brings up a regular Windows dialog box. And you'll see Project, Servers, and here's your WFS. You just double click that, and then it opens this, and it'll show you all the different things you could add from that link. And the one I'm showing here is from the Canadian Forest Service. This is the Fire M3 fire perimeter estimates. So you click that and just hit OK, and that's going to add it to your map. And you essentially get this. This is just an example I'm using because it still has fire perimeters on it, whereas no province currently was displaying that. This is 2023, obviously, but these are all the different satellite estimated. So these are made automatically and they're updated every time satellite data comes in, and it creates a rough perimeter. I often use these to start when we're doing projections for agencies. If they don't have anything yet, we can use this and start building off of it to get towards something. So now, with all that done, we've added a WFS, but we just got 2,000 fires across Canada. That's not very useful. Well, we'll zoom into our fire of choice. I picked this thing on the BC-Alberta border. It's over here near the Boundary Lake, aptly named. And we've got a web feature service, which is going to allow us to manipulate the data. So as what I said earlier, the WMS lets you see the data, but we can actually take the data from here. So from here, we're going to go on that map tab and we're going to click select. We're going to select the selector. And then you just click the fire and it should outline it in this blue. It'll outline it in some color. I don't know if the default settings do that. And then you have that selected as your fire perimeter, and you can go into the next step, navigate over to this new thing that'll appear, this kind of orange dialog box. It'll have a data section. Click that and it'll bring you the export features option. And then we can extract our fire and save that as a perimeter so we actually get to keep it and then use it in Prometheus. I recommend changing the output location because it's going to default to a geodatabase. That's a pain in the ass. Prometheus cannot actually take that. I don't think Brett can correct me or Neil, but I'm pretty sure you still can't access a GDB directly. So I recommend saving it out and putting the, somewhere else, just my documents, whatever. And then putting an output name it something useful. I recommend using the fire name, date and time you extracted it. Doesn't matter where you got it from. You don't want to end up using old data, and give it your fire name. I'm just Hearst Fire 4 here. And then give it the .shp extension so it actually saves it as a shapefile, and hit OK. So we've done all that. Now we've got a perimeter and we can add that perimeter to our map. It's the exact same steps here to add the hotspots in as it was for adding the perimeters. There's no real change here. I'm not going to go over that again. I'm being really repetitive. But now you have a perimeter and we can add our hotspots. I'm cheating. They've got these little black dots all over. These are not hotspots because I don't use ArcGIS very much. These are fire points for the past 40 years that happened there, but that's just to pretend we had data. So now we want to adjust that perimeter, and we're going to say that these 2 points here are where we know our fire went through. It went up here to German Lake and crossed near Boundary Lake. We know that from the satellite, and someone gave us that intelligence. We want to adjust that perimeter so the projection actually makes sense. So again, we're going to select the map. The test here is what I called it. We're going to hit edit. And we're going to enable snapping, same thing here, and then use the reshape tool. Click the vertex you want to use. Again, this takes some thinking. You might think, oh, well, this point's up here, so maybe the fire just did this. But that's not really super likely unless you have a better idea about that. In this case, if we were saying these are real hotspots, probably want to do something like, okay, we'll start here and we'll draw this out and maybe get that and then bring it in. It probably didn't cross that lake. And we got a little extension blowout there. So it's the same idea, same concept. You click your start vertex and just click around to make it nice. It's not going to be pretty and it's not going to be perfect, but it doesn't need to be because it's for Prometheus and that'll do a lot of the refinements for you. So outline as you need and expect. You'll bring it around, connect it to a point here where you want it to be, and then just right click and hit finish. And just like the last one, you did it. It's now done. Hit save and you've got a perimeter adjusted by hotspots. You can save this out and you can use it in Prometheus. It should go right in, same as all the other stuff. So that was really exciting, I'm sure. The next thing I'm going to talk about quickly is how to get some fuels and elevation data. This really differs by agency. Some provinces, you might just say to your GIS unit, hey, I need this extract for this fire, and you'll get it. Oh, go ahead, Dan.
Just to slow you down for a sec. Thanks, Sam. This is great stuff. One of the things you caught on, I think, Sam, which is really good, is that like you have to make a lot of assumptions with this stuff, right? You've got satellites detecting hotspots infrequently, from space. So sometimes, the smoke column's hot enough, it thinks it's a hot spot. Sometimes there's a pretty active fire, and for whatever reason, the detector up in the satellite misses it. So you have to make these assumptions, and Sam is drawing these squiggly lines. And as you could tell, I don't know exactly the resolution or what the scale was of the size of the fires you're showing us, Sam. They're, at least a few hundred hectares, probably several thousand hectares. So the assumptions you make are pretty significant, right? And you guys know this, it's like when you're flying around a helicopter, drawing on a map by hand, like sometimes you're, plus or minus 200-300 meters, sometimes up to kilometers, right? Sometimes the size estimates of your new perimeters are going to be out by 50%, right? Or more. So for that reason, you don't have to do all this precise stuff, right? Mm-hmm. And some of us either will, one of the good things is a lot of agencies do have GIS people. They might not know anything about fire behavior. So you can ask a GIS person to do this sometimes. And other times you just say, forget the GIS, I'm just going to do it in Prometheus. I'm just going to hand bomb it based on my underlying base map that Prometheus shows me a fuels layer. And at least I can pick out the lakes, usually the roads, and sometimes other features. And that's good enough to just look at, a map of hotspots and just eyeball it, because you're not going to be accurate regardless what you do. So that's just a bit of a, if all this GIS stuff is cool, like sometimes it's really good to try to, you want to do your due diligence. This is exactly where the hotspots were. This is, the series of assumptions that I made. I use these tools, and that's awesome, Sam. But sometimes you can just say, well, like you said, if you need something, you need an answer in 2 hours, you can just do it by hand and eyeball it and just document that as an assumption that you're going to be plus or minus 30, 40, 50% with some of your distances, some of your sizes. So I didn't mean to undermine what you're saying, Sam. I think it's all great stuff. It's just we're asking a lot in this course, right? We're asking you to take your fire knowledge and suddenly become experts in all these computing tasks that aren't necessarily related, right? And if it's all new to you, it can be a bit overwhelming. So the point is, some of this stuff is optional. So just thought I'd.
Dan, you stole my endpoint.
Oh no, sorry, man.
It's all good. Dan's got a good point with that, and it's kind of what I was going to get at the end of all this. This is a bunch of stuff, and I don't think most people here are doing GIS and coding and this kind of development regularly. I want to emphasize that you don't actually have to do this all. You especially don't have to do it all on your own. There are lots of folks across the country that are very good at this, that can do this and want to help and support. I have zero issue if people want to reach out and say, hey, can you help me with this or get me this? I've had folks in the field just call me and say, can you do a Prometheus projection? I don't have the time right now. I need it in an hour. And you know what? I'll whip something together. Is it accurate? No. Is it perfect? Of course not. But it's something they can use to get a start on. And that's kind of my point here. You don't actually have to do all this fuel extracts and hotspot adjustments on your own. You probably will have other people, but knowing the background as to what's going on is beneficial, so you know how it's being done and if something's really weird here. It's if they just circled all of the hotspots, that's getting risky and a little not the smartest thing to be doing, especially for operational uses. But anyway, I'm going to rant about fuels very briefly. Every agency has a different access to fuels layers and fuels data. BC and Alberta generally have really good data, whereas going out east, it starts to diminish, and some agencies might have it, some might not, some might have it 20 years out of date. But at the end of the day, there is always something you can get access to. We have national fuels available at various resolutions. It's not easy to get right now, and for most of the purposes folks would be using here, you'd probably struggle to get what you need, but you can just reach out and request that. But I am going to cover slightly how you can get it yourself. Again, using QGIS though, unfortunately. Oh my, where am I? Yeah, so it's easiest to do this stuff with software and scripts like R and Python. It takes me under 10 minutes to make a full Prometheus project with the data extracts and pulls, but I'm not expecting you all to install and start writing your own code to do that. So I'm going to do this with QGIS and kind of show you. I'm not covering how to add all this data again, but you add your fire perimeter if you wanted. It's not actually required, but as Neil said, it's good to have that in there so you can get a feel for how big of the area you actually want to extract and add whatever fuel grid you have. And like I said, I'm going to send around that Word document that'll cover off where can I actually get fuels? What is the best fuel layer? Secret answer is there isn't one, but that's beside the point. Then we're going to go to the next part. We're going to open this processing toolbox here, this little cog. If it doesn't appear there, well, you are out of luck and you probably need to call someone to fix that because it's weird. But we're going to clip the fuel grid in QGIS. So we're just going to have that processing toolbox open up. We get this little search bar. Search for the clip raster by extent tool. This is very easy, and it is not the best way to do this. I really want to stress that, but it is a way to do it. It'll open up this dialog box here with a bunch of stuff in it that probably doesn't make a lot of sense to some people. For this case, usually what I do, going back to this slide, is I just zoom this out to a certain point that makes sense, measure it. There's a little measure tool up here that'll tell you how far your distance is and say, that fire's not going to go 20 kilometers today, so I can use that extract of this. This is whatever. And then I just use this option here, which is to use canvas map extent, which is literally what you are looking at. That's what's going to clip out of it. So click that. It'll automatically do all that, put all the alignment in there. You don't have to worry about what that stuff means. Those are the extents. But you do have to worry about this part. Assign a specified no data value to output bands. Optional. It's not optional for Prometheus. It will explode in your face. Set this to negative 9,999. And if that is no longer true, well, I lied to you. The next part, save to file. And you're going to want to be careful with this. There's some compression options here. Sometimes Prometheus gets really angry about it. Don't play too much with that. You save to file, give it a file name. We'll call it fuel grid. And then just hit run. And then you basically get that. That was the extent that we clipped out, and that should 100% just fit into Prometheus without a problem. You can do the exact same steps if you had an elevation grid under there, and you'll be able to get the exact same thing out of it, matched to it, and go with that. You can also just use this to extract your elevation. Brett Moore has some great tools for doing that, but again, that's more in the coding world. And then the last thing I'm going to whip through is how to add this same stuff to Google Earth Pro, because I think that's where this is going to find a little more use. So how can you add a WMS to Google Earth Pro? Start off, I really, really hate this. It's terrible because the system to do it is just awful. But Google Earth Pro is really commonly used in the field. A lot of F-bands rely on it. A lot of people rely on it because we just don't have good access to tools generally in Canada. And so this is where it comes in handy. So we're talking about adding a WMS. That's those same layers. And I'm going to use the CWFIS stuff as an example because it's national and at least gives us a good picture. What we start with is up in the corner here, there's this add button. Just click that. Like I said, it's odd. And we're going to go for an image overlay here. That's what we want to add to this to get this same data in there. Click the refresh tab, oddly. Give this a name first. So let's say you want to add a fuels layer, call it fuels. Hit that refresh button. And then that's going to bring you this tab, which has a WMS parameters option. You click that, and you go here to add. There's anything else you've saved will already be here. So I think that's something from BC. Again, not a big deal. Hit the add button, and same kind of process as usual. Put in that URL you've copied right there. Hit OK, and it's going to fill out this side and this side. So there's opaque layers, so elevation, and then all the other stuff. We got fuels in here. We've got active fires. There's all sorts of stuff, perimeters and fun stuff like that. We're going to add elevation, fuels, and fire polygons. Unfortunately, the way this works is absolute garbage. And if you add everything at once, it puts it all into the same thing and you can't see anything. I don't know why. So what I would recommend is you want to add elevation, hit add, call it elevation, and then hit OK. I've kind of had to skip some steps here, but this is the general view of what you can do. You got a perimeter, you got your fuel grid, you got an elevation under there, and you can click those off. You can pan around, scan around, and see all your stuff. That's the same thing. You can't extract a perimeter from this, but what you can do if you've ever used Google Earth is draw your own perimeter and just go around it. Things like that. And you can add the hotspots and just make that by hand, similar to how Dan said you could do it in Prometheus, which again, yes, you can. Just other options so you don't have to sit in that program all day. And yeah, that's the general idea of what I'm trying to get across. This stuff is not the most complex ever, but it's not necessarily easy for anyone because if you don't do this often, if you don't do this ever again for 2 years and then someone asks you to run a Prometheus model, you're probably not going to remember any of this. So if one thing comes across, give someone a call who does know how to do this. There's a fair number of us at the CFS. There's folks at the agencies that understand this stuff really well, and we're all here to help out with it. And if you want these slides, I will share it out. That's all I got.
Thanks, Sam. A lot of info. So the point is, there are ways, if you're beavering away alone in your piece of the world, to get all this stuff from the internet, right? The fuels, fires, the hotspots. You're an F-band trying to save the world alone from your office. It can be done. As Brett says, don't beaver alone. Yeah. So you're probably working with some colleagues who can help with some pieces of this. And people like Sam are really good at it and can help out. And for the purposes of this course, if you don't have data and you want data, Sam is an excellent resource, and has offered to get people things like fuel grids. So you can run simulation on a fire of interest, for example, for your final project. He can get you weather data. He can get you hotspot data and perimeter data, right? So what do you need? Fire behavior, fuels, weather, topography, and a fire, right? So those are all things that you got to put in Prometheus, and people like Sam can be an excellent source. But it is a pretty cool exercise to actually know how to do it on your own from the internet with free publicly available tools. And so you can watch these videos again to take it step by step. If you know GIS already, that's a big part of it. If you know things like working with WFS and WMS tools and a little bit of kind of internet savvy for getting documents and files, that's a part of it too. And obviously, if you're just working in Google Earth, it can be done, even if it's maybe not the optimum tool. Sorry, I'm kind of just yakking away on stuff that Sam already said. So I just wanted to give a little space there, people to collect their thoughts if there were any questions. And any final questions for Sam?
I'm all washed out. There we go. Thanks, Sam. One quick question about using a WMS with respect to data import. Does that snapshot, does it pull in just the snapshot, or does the WMS automatically update as it's updated on the web every time you open the application?
So that depends entirely on how you set up your parameterization. I did not cover any of that. Depending on what it is and how it is, some of the layers will not update. With that CWFIS one, for example, you can have it update different things like the hotspots as they come in, the perimeter adjustments as they come in. Generally, though, if you just click once and pan around, it's going to automatically refresh it. But if you're not doing that, it won't most of the time.
As a non-advanced user, it'll be just for that particular snapshot that I pulled it from at that particular time. And if I want to update it, I'll have to add it again.
No. Sorry, it'll always update whenever you connect, add it, or move the map in any way. It will refresh itself. It just, if you don't set it to automatically do it, it might not automatically refresh. Does that make sense? If you had it open in your JS right now and you clicked once and moved the map an inch, it's going to refresh all of the data.
So it's
as long as you're telling to.
ping the server again and then draw in an updated thing. So if I'm in the middle of adjusting my perimeter, whatnot, and it just so happens that the source data gets all of the new Modus hotspots coming in, all of those new hotspots will suddenly appear.
Yep.
Okay.
Yeah, that's one of the benefits of doing this over downloading it, is you don't have to do any more work. It's right there. It'll update on its own, and you get to just do your job and not worry about monkeying around with data.
Sounds good. Thank you.
And systems like Google Earth are nice for that, because once it's in, it's in. It's a part of your My Places folder. You don't really have to think about it again. Whereas structures like QGIS or ArcPro, you would have to save an MXD or a QMD and then open those back up, kind of thing. I mean, it's a blessing and a curse in Google Earth, because then when it boots up, it loads all the things if you forgot to shut them off before you closed Google Earth. So when your computer grinds to a halt, lights on fire, and lets the smoke out, that's why.
Yeah, that I should warn you on that. If you add all these layers to Google Earth and then don't remember to delete them, it will. It happened to me this morning because I was testing all this, because I don't do this often, and it crashed my laptop. So it's not great.
The other point is, I guess, that most of you come from provincial territorial fire management agency, where GIS is part of your daily business in some level or other, right? So it's pretty tough from the training perspective to know exactly what your setup is. You know, at your job, if you're in your office, you're connected to some corporate database that's got all this base data that's from, you know, Alberta or from Ontario or whatever. It's going to look a little different than someone else's. So I think Sam did a really nice job representing kind of the more agnostic kind of like, you know, if you're not in that environment, here's kind of what you do. But you have to tweak some of this. Some of it, the steps will be a lot easier to do just within your own GIS work environment. There's always the issue of access, which is a bit of a weird one. I know that when I was in BC, in theory, there was a massive GIS infrastructure, but you couldn't really access a lot of it unless you were sort of part of the approved GIS specialists. And to be one of those, you had to sort of have training and, you know, have a job that related to GIS. And, you know, you had to kind of jump up and down and scream a bunch, you know, to get access. And so in theory, some of these things could have been easier, but, you know, there were security layers. And so you ended up working in Google Earth anyway, even though, you know, just because you didn't have access to underlying files. So it depends. It really depends on your personal work situation. But Dana is up next. And Dana, I'm sure you have opinions about all this stuff too, but you've been quiet, but that's okay. Maybe that's what retirement brings. Retirement softens the ranting a bit and the strong opinions.
No, I still have those.
I was gonna say,
Do we want to
have you
take a
met Carrie?
5-minute break?
We could take another 5 minutes, another good time for me to stop the recording too, I guess, and start up again. Although we said we wouldn't do that, but it seems sort of natural too. So, yeah, you call the shots, Dana. I'll stop talking. When do you want people back?
Yeah, let's say 7 minutes after the hour.
Literally 5 minutes. Okay.
Yeah.
Great.